welcome everybody. Welcome to the online people. Welcome to the in-person people who get lots of pizza each. We are going to kick off. We do not have a big audience today. However, we do have a very cool topic that I'm very keen to understand. So I'll hand over to Praveen shortly to sort of kick us off. There's not much in terms of announcements. We do have some in-person events coming up interstate and internationally. If anyone is interested and wants some details, the closest one to home is Brisbane on the 20th of July. Our camera's dying again, which happens occasionally when we kick the desk. Give me a sec. No. For the people online, yep, there we go. We just lost our feed inside the room. So hopefully it's all getting resorted now. I apologise if you lost us for a second. There we are. This room sometimes does it. I've just got to keep an eye out for it. Brisbane, Christchurch, and then some stuff Northern Hemisphere in the second half of the year. So if you want any details, let me know. Otherwise, that's pretty much it for the moment in terms of announcements. I'm going to hand over to you.
All right.
Hey.
Okay. All right. Hey everyone, I'm Praveen Kumar. I'm the head of data services and data engineering at PointsBet. I'm here to talk about Cosmos. I think given the background of this group, I'll talk from a lens of a SQL DBA and kind of talk through how I've looked at it. And obviously, it's not a relational database, but very much aligns with a lot of the partitioning and the indexing and all of that we are used to in the relational base, but it's just a different lens and the performance aspect of it and so on. So feel free to interrupt any if you have any questions, pop it in the chat, or feel free to raise your hand and we can have a discussion. I've prepared a whole bunch of slides. I'm happy to take the conversation wherever. It depends on what the user group here is familiar with and which areas they would like to understand better. But yeah, feel free to interrupt as we go. Has anyone here previously used Cosmos or are familiar with what it is and what a NoSQL database is? Or so I'll just dive in. What I'll do, I'm not going to jump into a presentation mode. I'm just going to share it this way and so that I can jump between screens. So essentially on Azure, this is what a Cosmos database looks like. What you have is the first screen where it tells you the read and write locations, and then the databases and the containers that are in there. So for a SQL Server DBA, you want to look at this screen where it looks, we're familiar with AdventureWorks. So it's called a database, as we normally call it. And then the tables, so to speak, in our language are what we call containers. So the interface for interacting with Cosmos is from the Azure portal itself. You can query it. It's essentially a document store, and you kind of execute a query and then it runs and gives you the data. So I think one of the things that people confuse with NoSQL is the fact that No stands for not only SQL and not that it's not SQL. So it's pretty much got the same essence of a relational database, but time and again, we have to remind ourselves this is not a relational database. The joins are much more compute intensive. It's not meant for that. So the whole idea behind, or the rationale behind Cosmos is to kind of make sure sharding is the theme that you're looking for. You want to read one document or one row at a time, and that's it, right? If you have any sort of pattern where you're continuously querying a whole bunch, this is probably not the database. There are design patterns that you can cater for and so on, but it's more often than not like the Internet of Things has come in. There's a whole bunch of data points coming into databases. You don't want to store that on a SQL database. That's highly expensive. The storage is expensive. So this is kind of where it lands and so on. And also in terms of, making sure you have a cheap data store where every time you're talking to like a microservice kind of a concept where a single document is all you need for any given transaction, this works really well. So at a high level, this is the interface that you're looking at. You've got a whole bunch of tabs here you can navigate through. We'll jump in and out of these, but let me just kind of dive in a little bit into the database itself. So what you see here, items, this is the row, right? So there's something called an ID. Not sure if this.
Definitely good online.
Let me see if I can zoom in. Right. So there's just something called an ID, which is for a SQL Server DB, I would translate this to a row ID. So even if you have a clustered index, behind the scene, SQL has a row ID that's defined for you, and then you have the clustered index itself that you define. So that's what I would say I would call the person ID here. Now, if I look at the scale and settings, this is kind of where it gets defined. If you see here, I've defined my partition key as person ID. So for all of us from the SQL background, I would just say consider the partition key as the clustered index and the ID as a partition ID as the row ID itself. So the way it works is if you give a query the cluster index key, obviously it can do a row seek. It knows exactly the document to go to. If you don't give it, then it obviously needs to go to another index that exists and then come and fetch the data from the cluster table. It's pretty much the same concept here as well, but just for our reference, person ID, in this case, because I've defined it, that's a cluster index key. There are indexing policies, and unlike SQL Server, the way it works for Cosmos, it indexes everything. So usually when you're trialing out something or you're doing a POC, it's extremely fast. That's because everything is indexed and it works. When you do it at scale, then you start feeling the hit of the I/O. So you want to make sure you understand this extremely well. It's only not indexing a metadata column. What you want to make sure is you understand exactly what's indexed and what's not indexed. The setting, there's time to live. We'll kind of dive into this as I go with my presentation, but I think this is the high level layout of what's in Cosmos. Now, there's something called an RU as well. I'll talk to that. That's a request unit. It's similar to what we would say is the cost, so to speak, in SQL, explain plans and so on. But it's interesting how it gets calculated. And the costing for Cosmos is on RU and storage. Majority of it is going to be consumed on the RU side and depending on how you're querying it. There's a throughput that's auto, scale, and manual. I'll speak to that as well. So at a high level, just making sure if you're not familiar with how Cosmos works.
Just a question, please.
Yeah.
So when you say partition of person ID, so person ID, if I have a person ID of 543, right?
Yeah.
Like suppose in HR, I have a HR ID, right? Employee ID.
Yeah.
And you would have one yourself and everybody will have, right?
Yeah.
So how can you, in a partition, I'll only have one record, my record.
So I'll talk to what a logical partition is and a physical partition is. What you're referring to is a logical partition.
Yeah.
But even in there, you can have multiple records. That's how it is. Like, assume you're talking about a partition key in SQL Server.
Yeah.
Right? You have 4 files and 4 partitions. File 1, 2, 3, and 4, and the corresponding partitions of 1.
Yeah.
You can have multiple records in partition 1. Right? So you can exist with employee ID 475 in partition 1. So can Guru and so can I. Right? We're all in the same partition. We're on the same file on SQL Server.
Yeah.
Logically.
Yeah.
Right? But at the same time, you can have different partitions as well. So that's all it means, right? So it's the archive, it's the partition key that you would say back in the SQL Server world, this translates to.
Okay, but normally, like you could partition, like if you have billing, right?
Yeah.
You pay bills every month, every week, right? You can partition by month, right? So
Yeah.
because you'll be paying every month, maybe for many years.
Yep.
You have history, maybe 10, 15 years of billing
Yep.
and paying bills, right? So then you can partition by month because there's a large volume of transactions. In each month, you will have bills from all the customers you have.
Right.
Pretty much all the customers, they'll be paying the monthly bill, right? So that's
the same here, where you can have, say it's a monthly partition key. What you would then have is every month in the same logical partition, each of us as customers will have a different document.
that makes sense.
So that's basically what it is behind the
I
scenes.
just didn't get this person ID. So is that the partition key?
Because I've defined it that way, yes, it is.
Okay.
You can define what you want. It depends on your usage pattern. It's a read-write pattern that defines it.
Right.
Right.
Okay.
All right. So just in terms of what we look at, let's jump into how I create a container, right? So a container for all of us in the SQL world essentially is what we would say is a table. And we're trying to make sure we define it the same way. So create new database ID, that's AdventureWorks, that we understand is a database. What you can do is create a shared throughput. Is it visible online, or should I might zoom in a little? So shared throughput is one of the abilities that you have to make sure you're sharing the cost or the RUs that you provision between the containers. So in SQL, you create a database. If it's on a 8 core database, 8 core server, it's always shared. Here, it's not necessarily the case. You can define it per container. You can share it, but you have to define it at the time of the creation, right? So it depends on how you use it. It's case by case. If you know how your application behaves, you can define this. So that's the shared throughput across containers. You obviously then have the problem of noisy neighbors and so on. So if one table is taking up all the RUs, then you have a challenge with the others getting resource contention and so on. Two ways of provisioning RUs. One is auto scale and the other one is manual. Manual's a dedicated throughput. So if you say the minimum you can define is 400 request units, that means at any point in time, you are paying for the 400 units minimum, right? The moment you exceed that, then you hit something called a throttle. I'll discuss a bit of what a throttle is at a later point, but manual means it's dedicated. With auto scale, Microsoft's provided the capability for you to scale between, say, in the screen, you can see it's 1,000 RU. If you don't use the account, you get billed for 100 RU, right? And it gives you the flexibility to go up and down between 1,000 and 100, depending on your usage. Now, one thing to note is the billing is per hour. So if you run a query and it takes 1,000 RU for a second, your hourly billing is for the 1,000 RU. So if you have a pattern where you're not sure or you're trying to figure out where it should land, autoscale is a good starting point, but the catch is that it is more expensive than manual. So if you know the exact usage, you probably want to stick to manual. Otherwise, autoscale is a very good starting point. It gives you the flexibility to go up and down. There are a few when you scale up and down, there are a few partition or physical changes that happens behind the scene. I'll talk to that as well in a bit, but in terms of provisioning throughput, this is how it's defined, right? The costing is also mentioned there. I'll have a quick walkthrough. It's roughly 150% more expensive. If a manual throughput would cost you $100, the corresponding equivalent on auto scale would be $150. Container ID. So this is the one we spoke about. So we've got the table name. Let's call that the table person. And then the cluster index is a partition key, right? That's a person ID. So I've defined it as that. There's something called a hierarchical partition key as well. I'll kind of talk to that. That's basically in our SQL language, assuming a composite cluster index. You have 3 or 4 columns as part of your cluster index. It just lets you define that, right? It tells you how to order your primary table, so to speak. So the way, I think I have a slide that talks to the hashing and how the data is stored in Cosmos, but they've given this provisioning mainly because of some of the use cases that and again, I think this is a year or two old, the way the Cosmos has been used, there are more and more good use cases for using the hierarchical partition key. Any questions so far? All right, I'll go to the next one, which is basically the types of partitions. So there's 2 main partition concepts we need to understand in the Cosmos world. One's a logical partition and the other one's a physical partition. So the way it works is you've got the logical partition, which again, we said person ID is what we're defining the partition by. Now, there are a few constraints on each of the logical partitions. You can have an upper limit of 20 GB per logical partition. So say to your question where you said every month, you want to do a partition by month. If you exceed 20 GB of data, Cosmos cannot scale, right? You get stuck at that limit. So when you design your partition key, you need to factor that in. You can have n number of documents. There's no limits to that. Or possibly there is, but it's a very high number. But you can't exceed 20 GB. So if you divide by monthly, the billing, and you exceed 20 GB, that's not a good design. And that's probably where hierarchical partition key and those kind of concepts come in. The other bit is each document can be an upper limit of 2 MB. Now, that's not really a logical partition limit, but you need to understand that as a logical limit for one single document, right? So if you have a bill, it's more than 2 MB, it's not going to scale. For MongoDB, there is a 16 MB limit, but I'm talking mostly for all intents and purposes. This is the SQL API I'm talking about.
When you say per, actually that's per row, isn't it? When you say per document.
Yeah, a single
per JSON document.
Per JSON, yeah. So because it's a JSON, there's it's just one big file. It can, and there's no way in Cosmos where you can do any partial reads. Like the concept of index in SQL doesn't translate well here. Like you can have a covering index in SQL, so you don't have to read the entire document or row. That doesn't exist in Cosmos. In Cosmos, if you're reading, you're interacting always with the entire document. So you want to make sure you've got smaller documents, because obviously when we speak to the RU side of things, where the resource is being consumed, it's heavy on how much it's reading, right?
We have a request online for you to zoom out.
Zoom out. Oh, yeah.
Just zoomed in on your slides. Oh,
Better?
thank you. I'm not quite sure the content of the slide was still covered, but yes.
I'll go.
There you go. There you go.
All my PPT designs are all the default designer stuff. It's not very fascinating.
That's good for.
All right, so the logical partition piece is that you've got the maximum 20 GB. You want to set up alerts for that. If you, by any chance, have any design issues that you run into, because more often than not, you find out only when you hit the limit, you can raise a ticket with Microsoft and they will temporarily scale it up to 30 GB. But obviously, you don't want to hit that. But yeah, you know you have the option to if you have to. Don't ask me how I found out. But
How did you find that?
so the next one's the physical partition. Behind the scene, in essence, Cosmos is like it's basically a distributed database. So they have a compute and a storage. That's basically all and everything about why Cosmos scales so well. The idea is they have an upper limit of 10,000 RUs per partition, physical partition. If you scale up, there's behind the scene, it splits into two, right? So even if you have no data and you scale up, you get physical partitions behind the scene, right? That is how Cosmos ensures you can scale. Now, if you scale back down, and I have an example where I talk to how sometimes there are performance impacts because of scaling up and down, you will not get the partition still remains behind the hood, right? That's something to understand. More often than not, you don't feel the pinch if you're doing a point read, which is a single document read and write, right? So as long as you're doing that, that works fine. It doesn't matter how much you partition behind the scenes. But if you're not doing that, and if you're doing something like a cross partition, which is like a full table scan in SQL world, then you will feel the pain. And I'll talk to why as well. So in terms of physical partitions, you've got that should be 10K RU, what you're seeing on the screen. The amount of throughput provisions, if you go to say 11,000 RUs behind the scene, you immediately get two partitions. The other bit is also if you have a 50 GB data set, if it goes to 50 GB and 1 KB, immediately behind the scene, there's a split. So those are the two things that can trigger a partition split. And that is in a sense how Cosmos scales, right? So if you want to have a picture of how Cosmos looks behind the scenes as a compute, maximum 10,000 RU for the compute and 50 GB storage. The moment you exceed any of those, it behind the scene provisions a second set of those, right? And then it splits how it stores and does the compute. Now, to give you a representation of what that looks like, so you've got a database on top, right? That's AdventureWorks in our SQL world. You've got containers for tables, and then the partition key, which is a cluster index. As you can see here, depending on your partition key, there's these logical partitions. Some are big, some are small, depending on the kind of skew that you have on your data set. That's how it looks behind the scene. So here at this layer is a logical partition, and behind the scene on the physical layer is a physical partition. This is what you don't control directly. Cosmos does it behind the scene. This is definitely what you control. You decide how this layer looks and feels when you're interacting with the database. Any questions?
Could you zoom in a little bit? I want to see the partition keys.
Partition key?
The partition key is city. Okay, so
Yeah.
the records that, so by default, there'll be like a skew in the data.
Yeah,
Like in this case, Rome has got more records than.
correct. So if you were to assume those blocks, each of them as a document, each of them can be a separate document, but you see that's a heavy. So if I'm reading one document and I'm giving them the detail of the partition key is Rome, but I also give the ID. So in here, in the first one, we define the partition key. There are, this is basically Rome, but you also have something called an ID, right? There's an ID field that gets generated, and this is unique. So this is a row ID, this is unique. If you give them both, then it doesn't matter if you're reading from a heavily skewed data point as well. You still get this one file for the minimum RU. So that's kind of where the design comes in, right? If you're reading from just giving Rome, saying, hey, get me the data from Rome, then it's obviously the skew affects it.
You're going to provide the ID too.
Yeah, so that's the concept of the point read. So similar to SQL, you want to do a row seek, right? You don't want to do a full table scan, get the data, and then filter it out. At the client side, you want to make sure you're navigating to the least or getting the least IO network, all of that. Similar to SQL, that's exactly what you're trying to do. But here, that concept is called point read. Occasionally, your design patterns can have queries, but not as a consistent pattern. So Cosmos mainly is for that single row kind of pattern.
Question?
Sure.
I see this example use city to make a logical partition.
Yeah.
But if one partition size is more than 20 GB, right? What should we do to split? For example, if we just, for example, in the data in the London, if it's more than 20 GB, it's unrealistic to find another key. We just should split the partition of London.
All right. Yeah. So the question is basically, suppose you design something with London as partition key and then it exceeds 20 GB, right? So that's kind of when you have the partition strategy come in. So there are a few options where sometimes you have people who say, let me do the partition key. And in fact, I think I have a slide that talks to it. So it's a good question. I've got a blank slide and I've got a slide that actually talks to the partition. So good question. It's a timely question as well. So you have a simple partition key, like the one we just saw, city, right? You can have a synthetic partition key that says London plus today's date, right? Then all of a sudden my 20 GB, I need to exceed 20 GB with London and today's date. Tomorrow I have London and tomorrow's date and so on. So may or may not be a good idea, because if I want to query then for London, I might go across different partitions if it's synthetic and that date.
We can use different key to participate.
Yeah, but then what happens behind the scene is you're not necessarily everything in London is going to this physical partition that you see here. You could have London on one day sitting here. London on the next day can go to the second physical partition. That becomes a challenge when you're trying to query for London, because then you need to go across physical partitions. You're going across files, across servers, right? This is not very good at that. The performance-wise, you will take a hit. That's kind of when hierarchical partition comes in, right? So hierarchical partition is where you define London and a date and maybe another field. And then it logically processes it into the same file. It's sitting next to each other. Cosmos does that for you, right? It does it automatically in the sense how it does spray the data around is by a hashing logic.
Okay.
So that is why it gets sprayed. So if you have a London, if you do a synthetic key with London and today's date, you cannot control which partition it goes and sits. If, for example, say a row, say you put a partition key 1 and a partition key 2, those documents will not sit adjacent to each other. Physically, it can sit one place and the other, right? You don't control it because the hashing logic takes care of that, which is good and bad, because that's kind of what makes it performant. It's not sitting in one place and you have a hot partition. But at the same time, if you're looking at this case, you want it sitting next to each other because I could then query London. I want it sitting in one place. So then that's kind of when you define the hierarchical partition key. And I think I have.
But logically, London data is sitting in the London partition.
It depends. So if to his question, he said he wants the 20 GBs exceeded with just London. So I can't use London as a partition key. So then what do I do? If I give dates, then how do I make sure it's still sitting in the same physical partition?
Okay.
Right? That's what we're trying to force. So that's kind of where this comes in. Assume the same container you have city, container ID. Here you get the first partition key, second and third. You get to define that. So in the SQL world, you want to look at a composite cluster key, right?
Yeah.
You're defining 3 columns and saying that's the cluster, order it by this and keep them next to each other.
Yeah.
Because I might look at London and a date, but I want them sitting next to each other, right? So that's kind of where the hierarchical partition key comes in. Again, you have to know the data, you need to know the design pattern. Will London exceed it? If that's the case, then you want to consider this early on. Yeah. So in terms of physical partition as well, this actually talks to that. You've got the hash. You've got the tenant ID, for example. I've taken examples that are not consistent with each other, but you assume it's a tenant ID. You kind of go into partition 1, partition 2, and partition 3. This is the stock standard London case, right? There's just a city being considered. Now, synthetic partition key has tenant ID and date, right? Or city and date, or tenant ID and user ID. That's kind of what it looks like. So Contoso and Alice, right? So if you see here, Contoso and Alice sits here, but Contoso and Bob sits here, right? Is that clear? When you look at it, they're not sitting adjacent to each other, they're going across. So if I want to query then for Contoso, it just goes across physical partition. And we always understand going across partition is not best when it comes to performance. There are extreme edge cases where that is the more performant, but more often than not, it's not. But here you can see, given that you've defined hierarchical partition, you're saying first do tenant and then user ID, it sits in the same physical partition. Right? So then you can define, you get more breathing space than the 20 GB that London had, right? You get more. But at the same time, even this can have, like if you're talking about large volumes of data, this can have it. So you need to be aware of your data points. And sometimes, in some cases, you're even partitioning it up to the minute and so on. Right? It depends. Like in IoT devices, sometimes that makes sense, right? So you want to design for that. So also,
Can I just ask one question? So for the physical partition, you really can't control which physical partition your data is. Like suppose you have London, would you say the date? So London, month of April 2024. Let's say I have London and month, London and April. I really can't control physical partition.
if you want
I can't control.
if you want to control, use hierarchical partition key. In the sense, you can't control where it actually sits, but you can make them sit next to each other. Right? You don't understand which physical server behind the scene it's going and providing and sitting at, but you can make them sit next to each other if you define it as hierarchical. Does that make sense? It's like a composite cluster index key. You have the city and then the date. So how it'll sit in the file is next to each other. It could be on the same page or.
Well, logically, they will be next to each other. So there'll be London, April, London, May, London, June.
Not if you don't define it as a hierarchical partition key, because
No,
hashing.
I do define it as a.
Then yes.
Yeah.
Then yes. Because otherwise the hash can just spray it around wherever. Right. So that's the best use case for hierarchy.
Yeah, and so the hash defines or drives the physical partition
Yes.
where the record is or the
Right.
document is.
Yep.
Yep.
All right. So we touched on this earlier. 10,000 RUs makes the physical partition split. 50 GB is a size limit. So if you go to 50 GB, 51 GB, then you have two splits. There's a distribution of throughput that happens when the split happens. I actually might jump into that. I've taken all my colleagues' names and shoved them into a ugly dashboard. But this is, assume we have four files, right? So we've got Pooja, May, Nikhil, and Praveen, right? Each of these documents, they're large documents. They take 10,000, 10K RUs to read. So just one file, if you're reading, assume it takes 10K. Another file, 10K RU. Another file, 10K, and Praveen as well, 10K. So total, I've given the container 10,000 RUs in total, and each file is 10K. So if I select start from this table or container, I'm expecting it to read in 4 seconds, right? That's the logical split for this to happen. Now, I scale up. I go up to 20,000 RUs. So my physical partition kicks in. Anytime I hit about 10,000 RU, there's a split. It splits usually from the middle, and it goes into Nick and Praveen in one physical storage, which has 10,000 RUs dedicated, and then Pooja and May in another file, 10,000 storage. Now I do a select star, 2 seconds. Double the RU, double the performance. Perfect. Now I go to 30,000 RUs. Now I have only split one of my physical files, right? It's 10,000 RUs per scale up or per partition. Now I have Pooja sitting on an individual partition, May sitting on a single partition. When I do a select star, they finish reading in 1 second. So they are faster, but this partition still takes 2 seconds to read. So there's a split 10,000, 10,000, 10,000. But overall, between 20,000 and 30,000, you don't see an increase in performance if you're doing a select star, right? And then there's a 40,000 where everybody's on their own partition. It's 10K, it's 1 second, right? So this makes sense. It's linear, only 30,000 stands out a bit. But there's an interesting case where if you come to 30,000 and then assume you scale back to 10,000, right? You came all the way to 30,000, you did 3 splits, and now you have scaled back to 10,000. Before you were getting the reads in 4 seconds. Now what happens with the scale back to 10K RUs is you have 3333 RUs per partition. The file still takes 10K RUs to read. This takes 3 seconds, roughly. This takes 3 seconds. This one takes 6 seconds.
Isn't there partition merge?
No, partition merge is a feature that's come in, but it's not compatible with continuous backups. So almost every container now is a continuous backup. So you don't have that feature. It's still to go GA. I think that's a limitation. But unless you do that, and that you need to trigger behind the scene, you need to man like all that feature. Otherwise, it stays this way. So time and again, you will see people scale up to see if the performance increases, and then they scale it back, and then you'll see the performance degrade as well. So again, this is not the querying pattern for Cosmos because the pattern is point read. You don't feel the pinch if it's a point read where it's going straight to the file. But if it's not, and you have a querying pattern, there is a case where you can go up and come down and then see performance degrade. This is pretty much the case. If you went to 40,000, you shouldn't feel the pinch again. You kind of divide that equally and then it runs again in 4 seconds. But this is a pattern that time and again merges, but it also gives you an idea of how the distribution happens behind the scene between the physical partitions and the RUs. Questions? Cool. So I'll jump into the next discussion point, which is the throughput or the request units. This is basically the currency of what we consume at Cosmos. What you want to look at is what constitutes a request unit. There's a whole bunch of things there. It's what you would expect, the normal SQL Server resource hogs, the memories, the CPUs, and the IOPS, right? So the larger the file, the more all of these cost us. So you want to make sure you're reading the least amount of data where possible, right? That's mainly what a request unit is. Now, with respect to read, you can see, I think there's a file which talks to, yeah. So let's take the smallest file, a 1 KB file, a point read will cost you 1 RU, which is really efficient. It's cheap and doesn't cost you much to read it, which is exactly why you want to keep the files small and then make sure you're reading only that file, right? So a point read, 1 RU. If you're writing the same 1 RU, 1 KB file, that's 5 RUs, right? On a query, it depends. If you're not doing a point read, it depends on the size of the query and how you're reading it, right? The indexes matter, a whole bunch of things matter. So what exactly contributes to the RU consumption? You obviously have the item size. You've got the indexing policy, whether it's using an index and it's able to get to that without reading the entirety of the physical partitions or doing cross-partition reads. Property counts as well in terms of how big the JSON is and how you've broken that internally. Data consistency. There are 5 consistency levels in Cosmos. The stronger it is, the higher it is, obviously, for you to read and write the data. Query patterns, again, similar to SQL. The cost of the explain plan depends on how you're querying it, and then scripts. So this is kind of like triggers for us in SQL world, where you insert something and then you can call a script behind the scene to run for Cosmos. You can define that it's a server-side script that you run that obviously then contributes to the RU of the call. How much time do I have? 20 minutes, yeah?
Give or take, yeah.
Question?
Sure.
So what the Cosmos do is just to make the partition for the such as BSON or the structure of MongoDB. BSON. How to spell
Is it a key value pair?
BSON.
JSON.
JSON, the storage structure of MongoDB. That's an example. So the index of Cosmos is just by the partition, but what's the index of the database will be worked by the database itself.
Yeah, so if you don't define an indexing pattern, how it's indexes everything, right? By default, every column is indexed. That's how it works. So if you look at the Cosmos indexing strategy, indexing policy.
You're saying JSON, right? Binary JSON.
Yeah, binary JSON.
Yeah, so what's the question?
No. I mean, he was trying to say binary JSON.
Yeah. So
the storage format, so to speak.
Yeah.
Right.
Yeah.
So here everything is indexed, and the index in SQL more often than not is a B tree. In this one, it's in Cosmos. I think it's a reverse B tree or something of that sort.
It's like a path, not the B tree.
Is that a question? I'm not following. So are you asking how it's stored?
Yeah.
The indexes. So it is a reverse B tree, if I'm not mistaken, how it's stored in Cosmos. So it's all pointers, unlike in SQL where it could store columns.
Yeah.
The indexes in Cosmos don't store any columns. It just tells you which file, which document to go and refer to. So all it has is a pointer, and that's all it does, right? So you can have n number of paths, and it maps all of it. If you don't define it, it will. If you have 100 columns and you click save, it's almost writing updates to 100 indexes.
Yeah.
100 key value pairs that column. Yeah. All right. So let's have a look at what this looks like. I've got the silliest of SQL statements that will run across the same query. So I'll just go to new, run this. Let's have a look at how it works. Gonna be a struggle for me. You're able to see the screen, yeah? Okay, there we go.
Better.
That's better. All right, so when I run this query, there's only one file in this presentation. We clearly not put in a lot of time into getting the adventure works sorted. But when you look at the query stats here, it's and I run this just saying select star, it returns a 4.51 RUs, right? It's technically only returning one file, depending on what I told you before, 1 KB file, and this is only 318 bytes. The problem here is it's running a query because you haven't told it it's a point read. It's running a query and it's returning 4.51 RU. Now let's see what happens if I give a where condition that's telling it exactly the ID. Weirdly enough, the RU increases, right? You don't expect this as a pattern where you're saying, yeah, I know you're going to read exactly one file, but the RU has gone up. Now, when I give it port, you can see the RU has come down a little bit. It's come back to 2.91. This query starts is quite interesting. It gives you a good idea of how it'll run. But the challenge with the portal is you can't do point reads. And you want to be always doing point reads in Cosmos. So this is not necessarily the best place to kind of tune your queries. You want to do it from the SDK, right? But if you are running, and more often than not, the troublemakers are queries, you want to come here and then tune it and have it play around and see how you go. Also, Cosmos, the way it works, it gives you a lot of trouble if you're running stock on production. So there is a new feature called query prioritization, I think. You can limit the thresholds from the interface itself on the Azure portal. Otherwise, even on the SDK, you can set the priority to low and run it. That way, you're not affecting your production queries if you're troubleshooting or playing around. So there are quite a few options there you can have a go at. So, yep, that's a quick walkthrough of how the costing works. Now, the throughput, I'll go back. There are throughput modes that we spoke about. The manual mode, which is minimum of 400, cost is fixed, and that's like basically dedicated throughput for your container. Auto scale, you can scale up and down. It is, in a sense, a dedicated capacity. So you don't have a situation where you request for, if say you've said 1,000 RUs, you don't have a situation where you're requesting for 1,000 and you don't get it. But that's basically why they charge you more. It's dedicated capacity, but you're not consuming it, right? So they give you that flexibility. The serverless throughput mode's a good one to use, say, for something you use once a day or so. You're not sure of the continuous usage of it. Say you're doing a bulk upload or something, that's a very good way to do it. There are limitations like 50 GB size, and you don't have a high availability region and so on. Obviously, because of the serverless nature of the workload, you have that as an option. Again, for business cases where you're not really, it's not a high value development piece, this makes sense. Maybe even in the lower environments, dev and UAT and so on, you could provision the servers as serverless. The problem is you can't swap it around between the autoscale manuals and the serverless. They've talked to the product team. I don't think it's on the roadmap just yet, but that would be a nice one to have. But yeah, one for you to know. The shared throughput one, again, creating the container and sharing it. So if you have 10 containers and you go with autoscale or manual, each of them have a minimum RU of say 1,000 RUs, right? So you may or may not use it. If that's the case and you don't know, or you're finding yourself paying a lot of price because of the sheer number of containers you have, maybe a shared throughput makes sense, and so on. Now, with the throughput mode, one of the things about Cosmos is, unlike SQL Server, where it just slows down, in Cosmos, you have the concept of a throttle, where if you exhaust your RU that you've requested for or dedicated to your account, it just refuses to serve your request, right? And that is exactly what Cosmos is expected to do. Now, that's not a problem. That's per design. So you need to understand this. The SDKs have a retry mechanism where they try 10 times and then they fail. So you need to design for that. It's not really a problem. Sometimes you get alerts on this. I don't find it a good use case to alert off, because that's exactly the Cosmos design. So the applications, the observability on the application side needs to account for, if this fails, how you want to translate that to a PagerDuty or anything of that sort. But it's one of those where it's per design and it's not a problem, and we shouldn't be setting up alerts because of what Cosmos is designed to do. What else have we got? All right, so when you create an account, a few things that you can see here. This is kind of what I spoke to. You have the region you can decide to pick. availability zones are available not in all regions. There are a few. So I would suggest you pick regions that have availability zones. If you don't want to do two regions, at the very least, you have a higher availability just because of the AZ capability. And then capacity is the provision of serverless. You can decide, but you can decide it only at the time of provisioning of the account. And it's at the account level, not at the container or the database level. And you can't flip and switch between the two. Yeah. And you can, if you have a few people who want to trial this out and you want to make sure you're staying well within the budget, you can limit that as well. So it depends on your use case, who you're provisioning or giving these access to. You can limit the throughputs that are allowed for the account to provision with.
Zoom in a bit.
Into this one.
Yeah.
This one. Yeah.
It's a twist top.
Maximum good.
Yeah.
Okay, cool.
Thanks.
No worries. The next one we have is the auto scale throughput. So as you can see here, the maximum RU in this diagram is 4,000 RUs. So you'll see different time of the day, they scale differently. So the minimum on a 4,000 RU is 400 RUs. So it's 10% is the minimum you can go to. And then the max is 4,000. So in a day between 3 o'clock and 5, this person's getting billed at 4,000 RUs. The rest of the time he or she's getting billed at a lower number. But again, if you notice this, let's assume this is 5 o'clock. He's exceeded the 4,000 RUs by a few minutes. He will get billed at this cost, right? It's per hour, the maximum. Product teams got more than a few people asking for that to be reduced to a per minute. But obviously, that's not in the roadmap just yet, but they are looking at it. I'm not sure when that'll see the light of day, but that would be a massive game changer for this, because a lot of the patterns we're seeing are pretty spiky in nature, and it doesn't really make sense or translate well paying per hour. The minimum you can pay, or the unit for Azure billing, is 100 RU, which is also why you see the auto scale maximum 10,000 RU, because 10,000 RU's minimum then is 100 RU. You're paying the minimum there. Right. So this is a rough estimate of how much it costs you in standard throughput. That's 5,800 versus 8,760 for auto scale. So roughly 150% expense. You need to obviously calculate if you're having reservations and things like that. It pretty much stays the same, but it's 150 times more expensive. Yeah. The Azure Advisor does a fairly good job of pointing out a few things in your environment if you have it, saying, hey, there are these many databases that need to be changed from manual to auto scale, or auto scale to manual, or vice versa. So it's a good feature. They've got a lot of Advisor things in the roadmap that the product team's working on, so you should have much more granularity in the coming months, but keep an eye out there. They're really surfacing a few cases where you can look to design things as needed. Now, from the SDK itself, we saw it from the Azure portal, how to get the metrics. You can do the same from the SDK. You just set when you're troubleshooting, populate the query metrics is equal to true, and then it gives you an output that pretty much looks like that. It just gives you all the details as to pretty much the SQL stats IO equivalent of the SQL world, where you get a quite in-depth understanding of which partition task, how many documents are read, and so on. It's pretty detailed and can help you troubleshoot. It's a very good starting point for you to kind of navigate. There is populate index metrics as well. So this is kind of telling you or asking for index hints. Like when you run the query, it'll tell you how much of, on the right hand side, what you see here is pretty much the output. This block is when you set that index metrics to true. It'll tell you how much of the index is being used, if there are any suggestion index, and so on. So it's another one you can use. Even on the advisor side, on the Cosmos account itself, now these are popping up saying this account could do. It's similar to SQL missing indexes. you don't want to just enable it. You kind of look at it, make sure it makes sense in your world, and then implement that as an index. I did the demo for the query stats, so I'll just skip that piece. I've got about 8 minutes. Now, indexing in Cosmos, you can index a single key value pair. It stops there. The star basically makes sure everything under that is indexed. You can exclude indexes if you know that there are data points you'll never query off in the where condition. That's a good one to consider, and it's a lot of the pain points for writes are used extending is people not excluding indexes. By default, it's a star, which includes everything. You want to make sure you're not defaulting to the star. So you know exactly what you're indexing. Starting point, maybe, in the dev environment, so on, that's fine. But when you're getting into a stage where it's going to prod, you probably want policies and stuff like that, where it captures and only exceptions go with the start to prod. The advisors are also pretty good with indexing, right? All right. Now, the index type, I think I'll skip this given we've got 7 minutes.
Go over a bit.
Sorry?
You can go over a little bit.
Okay. I think I've got a couple more that I want to touch on. There's quite new features as well.
Yeah.
So let's skip the indexing mode. It's fairly up standard. It's not much value. Just indexing mode is fairly consistent. There are a few, if you look at the database itself, there's automatic and things like that mentioned. It's, I think, deprecated. The lazy indexing mode is also deprecated. You need to call an old API to provision it and be able to provide that. So it's no more a thing. Time to live is an interesting one for Cosmos databases where you want to not store data that's old. There are 3 settings in time to live. There's off, which makes sure nothing ever happens to the document. Everything you write stays there till you explicitly delete it. You can have it as on and no default, which means the time to live or the document stays on unless you have explicitly said this document can be cleaned up after a certain time. So you're writing it with the information that this document needs to live on for 3 days and so on, right? So the design pattern takes care of that. And then you have an on, which is by default, it sets a value. If while writing, you set a value to the doc, that overrides it. So this is by default if you don't provide a value. Otherwise, this is a fair way to write and make sure your data size is not growing. So as I said before, the 50 GB enforces a split. If you want to keep your database clean, it's probably a good way to make sure, data, if it's not needed, maybe 7 days or 10 days or whatever the business logic is, it cleans up on its own. It's like a garbage collector kind of concept where behind the scene it goes and cleans up. So if there is RUs to spare, it just goes and does the deletion when it's in its own due time. So it's easier for you to make sure you're not maintaining that cleanup part of the process, and it's behind the scene maintenance kind of a job.
One question, please. Is it a hard delete or is it an archive? Is it archived to back?
No, it's a hard delete.
Hard delete.
Yeah.
So gone after a period.
Yeah. So you have continuous backups and things like that, which you can use to retrieve the document back. But unlike, there is a concept of change feed, which captures updates well. It just points to the document itself. But in cases of delete, it doesn't. Right? It's not the CDCs of the SQL world. It doesn't have anything to point back to. So it doesn't capture deletes. So the product team's looking at a few features there, but nothing yet for delete. So if you delete something, it's gone.
I think that concept still freaks out database administrators, traditional database administrators. Like, you delete data? What? Huh? No. But no, it makes sense in the more event streaming type scenarios. Yeah. You could store everything, but then you'll be out of space in 5 days.
Yeah, pretty much.
Yeah.
So this is an easy one, and time and again, and if you're in a consulting job, you'll see this as an easy fix. You want to make sure you're asking the people if they know this feature exists and they can implement it, because this quickly clears up a whole bunch of space for you. Obviously, then performance and so on. I'll run through a few features. I've got about 4 minutes and a bit, but yeah. So burst capacity is
10 because we started a bit late.
Okay. Burst capacity is a good one that I like for any containers I'm not sure if you can see it.
That is like the worst text color ever.
All right. So burst capacity is one of the features where if you're under 3000 RUs, you're provisioned. You have to enable this as a feature. I think going forward, I'm not sure if it's a GA feature or not. By default, any newer ones probably will have this here on. But if you're on an older version of Cosmos, you want to enable this feature. And then what that allows you is if you're not consuming your RU and you're under 3000 RUs, it allows you to bank 5 minutes of the idle capacity and then use that to hit up to a rate of 3000 RUs. So it lets you say if you have a spiky load, it lets you kind of provision a low or keep your scale at a lower limit. And then when you have the spike come in, then you burst, you hit a 3000 and you're able to use that for up to 5 minutes of the idle consumption. So because you're paid for it already, the way the billing works is you're paying for whatever you've provisioned, right? Manual or auto scale, you're paying for it. So you're banking on that. So Microsoft gives you, but to an upper limit of 3000 RUs. So you want to enable that anyway. There's no downside to it. So all of your databases, you can go and enable this flag and make sure it's in the code base and updated. But if you're provisioning new ones, I think by default it's enabled. It's a good one to have. I can't see a downside to having this in place.
This is happening in Fabric as well.
Okay.
Bursting is coming through in a lot of the Fabric workloads.
Okay.
So Microsoft are really putting a lot of emphasis on it in terms of if you don't use that capacity in the next, day, you can still have it. You can still use it, but there's like you said, there's limits.
Yeah, I think
but it's becoming more and more of a thing.
Yeah, because you're paying for it, and if you're not using it, obviously you've got disgruntled users.
You still get throttled if you burst beyond.
Okay.
You've got limits on how far you can, go up to.
Right.
Yeah, they're starting to do that in more products.
Yeah, that's good.
It's cool.
That's good to hear.
Yeah.
Another one which is not very clear. It's dynamic scaling.
I reckon you use SAC Copilot.
Sorry.
SAC Copilot.
I think that I've got a link in there. That's what it is. So it kind of connects to the Microsoft document for it. So the way the RUs work is if you have two partitions and like one of the examples I showed before where I had 4 partitions of, with one partition I had Praveen in there. And say I run a query on just Praveen and I take 1000 RUs. What happens is if there are 4 partitions, all the 4 partitions get 1000 RUs scale. So the costing was across all partitions and across all regions. So if I had a secondary region, my billing was happening twice. Obviously, this doesn't sit well as a customer when I'm paying money. Like I'm reading data, I don't need to be paying for the secondary region. Microsoft's come and addressed that where they've said per partition, per region, they're able to scale and bill you according to that. So if you have a read write, say multiple zones, you also have that costing difference that can kick in. But say you're using it only for HA, then it's a big game changer if you enable this feature. This is, I think, going GA soon, but I think you can get Microsoft product teams are very excited to implement this. So you can reach out to their customer, raise a ticket with Microsoft and get them to enable this. They will do the analysis and tell you which ones are best fit and then enable it. I don't, again, see a downside of implementing this across everything anyway. Best case scenario, you just pay the same amount today that you do today. Otherwise, you get a cost benefit. This is the priority-based execution. So the one I was talking about before, where in the SDK, you can define, when you're troubleshooting, just define the priority level as low. Even suppose you're doing a bulk upload or something like that, you want something running in the background, this is a good one. That way your end users are not impacted or you're not throttling other more business or relevant queries. It just makes it easier for you to make sure that you can sneak in a few low priority tasks using this. Redistribute throughput across partition. That's another feature. It's not really new. It's been there for a while. So the thing we spoke about where there's a hot partition, you can define one partition to have higher. This is not recommended. It's usually a flaw in the design or your data skew is not, you want to address the data skew, but say you have a production issue, you can get Microsoft on the call and then get them, or I don't know if you can do it yourself, but there is a capability that or a feature that allows for you to allow you to focus more RUs on a single partition. So if there's a hot partition and you want to make it through the sprint with, the peaks coming up, this is a good one to consider. Merge partition, this is the one which Guru spoke about. Again, not a new feature. It's not going in PA. It's the ability to merge back the partitions into one. The challenge really is, I think it doesn't work with continuous backup, which is, I think, every new container, the standard for any new container provision. Now, there is an option for you to also do an intra-container copy. You can just create a new container and copy it into a new one, which then sits in a single physical partition. So that's another one that's pretty quick as well. Before, I think you had to use ADF or Databricks or something like that to copy files. There's you can just now run it from script. Also, there's a change partition key in Azure, which is in preview. So it allows you to change the partition key, which sounds like, you're making a clustered table into a heap and then rebuilding it, but that's not what really happens. It's using intra-container copy and it's copying it elsewhere and then copying it back. So it's basically writing into a new table, so to speak. That's what it does behind the scene. But that's another one. You need an outage when you're doing that because it's not behind the scene kind of a process, but it's an easy one if you've got the partition key wrong. I think that's pretty much all I had. I think.
If you've got questions online, feel free to come off mute or type them into the chat. Any questions here? I think we were kind of asking as we went, weren't we?
Yep.
Cool. No questions? Yeah. Awesome. There you go. You got done in just less than an hour.
There you go.
There you go.
All right.
Good. We'll give it a minute or so too to see if anyone online wants to chuck in a question. But I found that really informative.
Thank you.
That's really helpful. Coming from SQL Server world, going Cosmos, evil, go away. Actually understanding it a bit more. So I thought that was really good. Nothing else? Like I said, I'll stay online for a couple of minutes or so, but
Just one thing. One thing I wanted to ask is whether this is only on Azure Cloud or can it be on-prem?
Well, it is only on Azure Cloud. When you say on-prem, if you have, you can get Azure on-prem. I don't think that's your question. Yeah, it's primarily an Azure document store.
But you can't get Cosmos DB on-prem.
There's an emulator and things like that for you to troubleshoot on your desktop, but not on-prem. Yeah.
Because finally, where I'm working right now, we got most 80% of our systems still on-prem.
Yeah. Yeah.
Surprise, surprise, but that's the way it is.
I like to see that as you got 20% in the cloud, and that's a start. No?
Yeah. Well, amounts to that.
Yeah.
But that's the reason I asked you.
Yeah. So there are quite a few challenges with Cosmos as well. Like the access is not as granular as SQL and so on. Like your row level protection, things like that, you don't get here. So technically it should be the cheaper option because of the throttling and things that you don't want to use it for things that are mission critical. If you're working in health and things like that, there may or may not, but you've got to get the design on point if you're using it for that. Otherwise, I think, for non-relational stuff, this is an extremely good, cost-effective store, but you have to design it right.
I think that's just it. Use it for what it's intended for. Don't use it just because it looks pretty.
Yeah, that's pretty much a challenge. Because also, if you think about how a discussion goes, a product team comes and says, I want to do this, and you have the MVP out, the next version of what they want will likely change the behavior. So you've got to design for that. So there are a lot of, you can use the change fee to write in the same data into a different container for a different purpose, but that's the main challenge with Cosmos. Relational databases with SQL, you can write a lot of ugly queries and it'll still perform. You can write indexes. You can keep the app above water. It just does its magic. SQL is very good at that. In this case, it just doesn't scale. If you are trying to change the read-write patterns, you have to design for it each time.
Right.
Cool. All we got was a thank you. online. So
All right.
I'm happy
Thanks, Anoop.
to close it down there. Just for those people still listening, still trying to work out what our next meeting is going to be, and what we're sort of going to cover. It's kind of getting to those really cold Melbourne months where we don't really want to come into the office. So we'll see how that goes. And I won't be at the next one because I'm on holiday.
All right.
So we'll let you guys know. Stay tuned to the meetup. I have had this recording, so I will stop the recording in a second. Hopefully it'll work and I can upload it to YouTube. And I will put the link out there in the next few days if you want to go back and have a look. Otherwise, thank you very much for your time this evening on short notice as well. Like I said, I learned something. A few people online seem to have learned something. So I think that was really, really helpful.
Thanks.
Yeah, thank you.
Thanks, Steve. Bye.
Thank you. What's with all the food? Are you going to keep it in the fridge?